Hello students, Miss Slyman here with your notes on the tangent function. So remember that tangent is sine over cosine, of course, and we've got our unit circle with radius 1 and that p gives sine and cosine. So how can we use the coordinates to find tan? Well, you can divide the sine value by the cosine value, the y value by the x value. And remember we said that's the slope of each. So you can go ahead and follow these directions to create your tangent graph that way. But I had a brainstorm last night, and so I've added in a sheet that has a sine graph and a cosine graph. So if you have already printed yours off and don't have this sheet, no problem. Just go ahead and graph sine and cosine from negative pi to 2 pi. And so notice in red here, that's going to be my sine graph. So my red is sine, and my blue is cosine. It doesn't fit. And so again, we're going to think about dividing sine by cosine. Well, so that means I'm dividing the red value by the blue value. So let's go ahead and do that. If I start over at negative pi, so over here, the red value is 0, the blue value is negative 1, 0 divided by negative 1 is 0. So I can plot a point here. Okay, so now I have, looking at the next easiest one, that's here. So here I've got that the red and blue are equal to each other. So when I divide red by blue, it's going to be equal to, and think about this, they're both negative and they're equal to each other. So it's going to be equal to positive 1. So following up, so I have the same theta value, that's up here. So let's go back to what we missed. So somewhere around this point, here's my negative 1/2. So that corresponds to about here. So I know that if x is negative 1/2, that means that the y coordinate there is going to be negative root 3 over 2. So negative 1/2 divided by negative root 3 is going to be 3 root 3. That's some sort of positive value that's less than 1. So I can put that in my calculator just to look at it. So let's look at 1 divided by root 3. And that gives me 0.57, so just greater than 1/2. I'm following at the same, trying to stick with the same theta value. So again, I did this value, so that was negative 1/2 divided by negative 1/3. Sorry, negative root 3 over 2, which gave me 1 divided by root 3, which is about there. Okay, so as I continue along, now I see that my red value is more negative than the blue value. So when blue is 1/2, that's going to be over here. So now when blue is 1/2, that means that red is negative root 3 over 2. So that's going to turn into negative root 3 divided by negative 1, which is just positive root 3. Put that in my calculator, I get 1.7. So that's going to be up at 2/3, so greater than 1. I'm counting every 2 as 1/2, so even already it's going to be up here somewhere. I'm up there. So that was dividing this point divided by this point. And now if I think about what's happening here my y value is 0, my y value is negative 1. Negative 1 divided by 0, I'm not allowed to divide by 0. That puts in an asymptote. And of course, if I think about where this is happening when sine is at negative 1. So this is negative pi over 2, that asymptote just happened. Okay, let's think about what happens immediately after that. So immediately after that, my y value is like, let's say negative 0.9, and my x value is going to be, I don't know, around 0.2. So negative 0.9 divided by 0.2 approximately is negative 4.5. So right at this theta value, I'm way down here. So somewhere down here. And then I have that now when y is negative a half, when sine is negative a half, cosine is positive root 3 over 2 up there. So negative a half divided by positive root 3 over 2, that's going to be negative 1 divided by root 3. So it's going to be negative 0.57. So the negative of this value here. So that happened at a half for the sine value, and it ends up somewhere around here. If I skip over, now I see that when sine is 0, cosine is 1. 0 divided by 1 is going to be 0. That's a point. Here they're equal, both positive. That's going to make it positive 1. So I was talking about here, they're equal and both positive. And here, cosine is 0. 1 divided by 0 does not exist. So I have another asymptote. In fact, every time cosine is 0, I have an asymptote. I'm not allowed to divide by 0. As I get closer and closer to that point, I have big number divided by much smaller number. That's going to make it really big. It's going to go up towards infinity. So what happens is I go up towards positive infinity and then down towards negative infinity. So my tan graph ends up making, so here again we're at 0. 0 divided by negative 1 is 0. Now I have positive divided by negative. It starts with big positive divided by very small negative. That's going to be very small negative. And then I'm going to get positive and then come up. Here is my, when theta is here, these are at my 45 degrees or my pi over 4s. When I have these values, that's when tangent is going to be equal to 1. So I should have made my 1 be right there, not on the 4 pi thirds. And this is what's happening. So tangent repeats. Here's going to be my 0, and I'll come up. And the curve is making this shape. So here's the general tangent graph. It's bordered by asymptotes. If I fill in this side over here, I have the positive branch of it. And because these lines here, I've got negative pi over 2, my next one is at pi over 2, this one is 3 pi over 2. So anywhere that cosine is 0, notice that this distance here to here is pi. So I'm repeating every pi. So yes, it is periodic. The period is pi. For what values of the angle theta does tan not exist? Well, that happens at cosine theta equal to 0, which happens at multiples of pi over 2, odd multiples of pi over 2. So pi over 2, 3 pi over 2, 5 pi over 2, so odd pi over 2 multiples. Positive or negative, of course. What are the x-intercepts? Well, the x-intercept is when y is 0, and those are happening, so that's at y equals 0. That's when sine is 0. So those are multiples of pi. So n pi. And that's what our theta would be equal to. The range of this function, negative infinity to infinity. And of course, our domain, x can't be equal to any of these. So if I want to know when tan of x is equal to 3, well, first of all, I need to draw a graph that has a higher y-axis, but I'm going to look at the 3's. Those are going to be really close to my asymptotes on the positive side, but I can look at the graph and find the points of intersection. Okay, I've got a class coming in, so I'm going to stop the video here and I'll come back to show you these graphs.